In this lesson, we will talk about our matrices, and we're just going to start with a simple introduction. And the whole idea of a matrix, that is going to be a rectangular array of variables or constants in rows or columns, and you're usually enclosed by brackets. And that's just in general what a matrix should look like. Okay, and then elements are inside the matrix. So here, a formal way to put that, elements are the individual values and within the matrix. And then the next part, you have an element, and normally you're going to note that with a subscript is going to be used to denote where X is the row number and Y is the column number. All right, so looking at our first example here, it wants us to give a matrix A, find the value of each element. So for the first one here, they give you 2, 5. So what that means is you're going to go to the second row, and rows run left to right. So the second row, and then the fifth column. So 1, 2, 3, 4, 5. So second row, fifth column, that's going to be element -2. So number 2, we're going to go to the third row, and then we need our first element, so that's going to be +5. And then for number 3, we need the first row, second element, that's going to be 40. And number 4, third row, fourth element, that's going to be 52. And then number 5, the first row, and then the fifth element, 21. And then finally, the second row, second column is going to be value 32. All right, when we talk about the dimensions of a matrix, we are going to say a matrix with m rows and n columns is said to be an m by n matrix. And we would write it m by n matrix. All right, so again, notice that it's a row by the column. So for number 7, they want us to state the dimensions of each matrix. So again, rows go long ways, and columns, those are going top to bottom there. So this is a 1 by 3 matrix. Number 8, you're going to have 1, 2, 3, 4 rows. So that's a 4 by 1, 2, 4 by 2 matrix. Number 9, you're going to have 3 rows, and you have 1, 2, 3, 4 columns, so that's a 3 by 4. And then number 10, notice you have 2 rows, and you have 1, 2, 3, 4, 5, 6 columns, so that would be a 2 by 6 matrix. Now, when we talk about equal matrices, then we're going to make the statement that 2 matrices in which each element in one matrix is equal to the corresponding element in the other matrix. Now, it looks like I'm going to run out of room here. All right. So again, for two matrices to be equal, then each element in one matrix must be equal to the corresponding matrix in the, or corresponding elements in the other matrix. Now we have special matrices. A row matrix, that is just going to be a matrix or matrices with just one particular row. Notice that does have three elements in it, but it is one row with three columns. A column matrix will be a matrix with just one column. And then if you have a square matrix, then that square matrix is a matrix that has the same dimensions for your row and columns. So there would be a square matrix, and it doesn't have to be a 2 by 2. You could have 3 by 3, 4 by 4, and so forth. And then a zero matrix could be a matrix that all the elements in that matrix is 0. So again, you have four special matrices that you need to be able to recognize. All right, now addition and subtraction in matrices, and usually you see this on the ACT. Notice that in order to add or subtract, you have to have the same dimensions. And if they do have the same dimensions, then you add corresponding elements. So you do need to check your dimensions first. So notice on number 11, you have x plus y. So here's matrix x, matrix y. And notice you do have the same dimensions, and since you do, then you can go through and combine your corresponding elements. So in other words, 24 plus negative 15, so that's going to give you 9. And then you have negative 8 plus 29, so that's going to give you 21. You have negative 3 plus 17, so that's going to give you 14. And then your next row, you have negative 4 plus 9, so you're going to have 5. And then you would have 1. And finally, negative 17 plus a negative 2 is negative 19. And there would be your answer. So number 12, you're going to have matrix Z minus matrix W. So again, we do need to make sure they're the same dimensions. So here's matrix Z and matrix W, and they're both 3 by 2, so you definitely can subtract those. And now you just subtract corresponding elements. So negative 3 minus a negative 1, that's going to give you a negative 2. And then you're going to get negative 11, and then negative 5, negative 15, and then 4, and then 29. So again, you're just adding those corresponding elements there, or subtracting them. All right, number 13, we want matrix W. So I'm going to look at matrix W and matrix X. Now this one, notice you've got the dimensions 3 by 2, but matrix X is going to be a 2 by 3. And notice those dimensions do not match, so this matrix addition is not possible. And then finally, question 14, we need to combine our matrix X and then minus matrix Y. And those are compatible, so we can subtract those. And when you go through subtracting each element, you should get 39, negative 7, negative 20. The next row is negative 13, 11, and negative 15. For our next part, we're going to talk about scalar multiplication. And this is just like the vectors that we just finished going over. So for our first part, with our scalar multiplication, this means that we are going to take the value 3 or the scalar 3, and I'm going to multiply it to each element in matrix X. So I'm going to recopy the matrix X down for us. And then you're going to go through and you're multiplying each individual element by 3. So when you do that, you are going to end up with 3 times 24. So that's going to give you 72, negative 24, negative 9, negative 12, 18, and negative 51. All right, so for number 16, you're going to have 3/4 times vector W. So again, looking at vector W, 3/4 times that, well, you're multiplying 3/4 to each individual value. So you're going to have negative 3 over 4. And then you're going to have 27 over 4. And then next, you are going to have negative 33 over 4. Your next element, you're again multiplying by 3/4, so you're going to have 45 over 4. And then for your last row, again, you're going to have 6 and negative 15. All right, for number 17, you've got a couple of steps here. The first step, you're going to multiply negative 5 to your matrix X, and then you're going to multiply 2 to your matrix Y, and then you're going to add those together. So negative 5 times matrix X, you've got negative 120, you've got 40 and 15, and then we're going to come back to our next row. You have 20, negative 30, and 85. So that's all of this. And then plus, and now we're going to go through and multiply 2 times matrix Y. And if we do that, we have negative 30, we have 50, and we have 34. And then coming back around, we have negative 18, negative 10, and negative 4. Now again, notice that those two have the same dimensions, so now we can put those together for a final answer. And that final answer, again, you're just adding these corresponding parts. So you have negative 150, 90, 49, and then our next row you have 38, negative 40, and then 81. All right, let's look at number 18. This time we are subtracting. So the first part, though, we need 4 times matrix W. So 4 times matrix W, we're going to have negative 4, then 36, negative 44 and 60, and then 32 and negative 80. And then we're going to subtract matrix Z. So matrix Z here, we're just going to pull that down, and you're going to have negative 3, negative 2, negative 16 and 0, 12 and 9. Now finally you check to see they do have the same dimensions, so we can combine these for a final answer. And again, you're saying negative 4 minus negative 3, so negative 1, 38, then negative 28 and 60, and then 20 and negative 89. And that's going to be your final answer there. All right, in 19, notice that they want us to add your matrix W and Z and then multiply by negative 3. So I'm going to rewrite this, and I have negative 3 times, and then the sum of W and Z should give us negative 4, 7, negative 27 and 15, and then 20 and negative 11. Now you do need to multiply by your scalar, and so that's going to give us 12, negative 21, 81, negative 45, negative 60, yeah, and positive 33. And there's your final answer. Okay, and the same for number 20. Again, you're going to go through and you're going to do your subtraction first, and then multiply by your scalar of 1/2. So if we go through our subtraction, we have negative 39, 37, 20, and then the next one we have 13, negative 11, and 15. And now you go through and multiply with your 1/2. So you're going to have negative 39 over 2, 37 over 2, 10, 13 over 2, negative 11 over 2, and 15 over 2.